All right, guys. So we want to look into the concept of real numbers. The concept of real numbers. Actually, this video is going to be in series. I'm going to be treating the terminologies we need to know in real numbers. I'm going to be treating how to prove rational numbers. I'm going to be teaching on inequalities. I'm going to be teaching on quadratic equation. I'm going to be teaching on logarithmic functions. I'm going to be teaching on polynomial. So all this is going to be in the series of these real numbers. But for this video, I'm going to be mentioning the terminologies we need to know and we need to understand as regards to real number system. Now, the first thing you want to know as a student wanting to know this topic deeply is the sets of natural numbers. You know that sometimes you see some symbols and you feel like, what does this really implies? First, we need to know the set of natural numbers. The set of natural numbers. The set of natural numbers. Okay? Natural numbers. Now, what are the set of natural numbers? First of all, that we need to know. These are sets of non-zero positive numbers. Integers. Non-zero positive integer. I'll tell you what the meaning of integer. But they are non-zero, which means that for natural numbers, zero is not included. They are non-zero and they are positive. There's not like minus when you talk about natural numbers. Okay. What are the examples of those numbers? And we can also call them counting numbers. So example of natural numbers are 1, 2, 3, 4, 5, like that. Right, to infinity. These are sets of natural numbers, and it is denoted by this symbol, n. That's set of natural numbers. They are non-zero positive numbers, integers. Okay. Now, what do we mean by integer? That's the terminology that we are going to be checking. Set of integers, right? Integers, these are sets which involve both the positive and the negative numbers, including zero. Now, when we talk about integers, integer is the set that involves both positive and negative numbers, including zero. So, in the set of integers, we have zero. It is denoted by this symbol. By this symbol WZ, okay, by this symbol. And example of integers are an half from minus infinity, okay, like that. We have -2, -1, 0, 1, 2, 3, and like that, okay, to where we want to stop. So it involves zero, positive and negative all together, and that's how we work with it. So another term that you want to know is the set of rational numbers. Rational numbers. What are rational numbers? Set of rational numbers. Rational. Set of rational numbers. Okay. Now these are numbers that they are in the form P over Q. They are in the form P over Q, like fractions. Okay. Where Q is not equal to 0, because if Q is equal to 0, that means we call this type of expression to be indeterminate. All right, so it is not, Q is not vanishing. You can say Q is not vanishing or Q is not equal to 0. And P and Q, they are relatively prime. P and Q, they are relatively prime. That means the GCD between them is 1. Now, what's the meaning of all this word GCD, relatively prime? It means that by the time there's nothing that can go if I want to divide P over Q now, there's nothing that can divide the both of them except 1. Only 1. 1 is the number that can divide the both of them. For example, if I have 1 over 3, 1 over 3 is a rational number because there's nothing that can divide 1 and 3 except 1. So that's the meaning of two numbers to be relatively prime, right? They are co-primes. The only number that can go between them is 1. Okay, so having known that, we also have the set of, okay, for rational numbers, it's denoted by this symbol. You see a Q like this. This is for set of integers. This is set for natural numbers. Set of what? Integers. Okay, that's set of integers. And we also have set of real numbers. Now, set of real number embraces all the number system, right? Positive, negative, rational, everything. So we have set of real numbers. Set of real numbers embraces all. So you can be asked to, and set of real numbers is denoted by this symbol. Okay, that's set of real numbers. We also have set of complex number. Now, even when we're in primary school, you know that there are some times where we need to do some operations. Our teacher will tell us that it does not exist or it is impossible. For example, in primary school, if you are in primary school, maybe like primary 2, 1 minus 2, your teacher will tell you, or you will assume that it is impossible. But by the time you grew up into probably GS1, you know that this will be minus 1, right? So as you also grow up in the university level, you get to see that the square root of minus 1, if you should see this in primary school, you will be like, this is wrong. But as you move on, you know this is I, right? Do you get? So now there is an extension in real number system. That extension calls to something we know as complex numbers. Complex number is an extension in the real number system, and it's denoted by this. This is how complex number is denoted. Alright, so if you want to check the relationship between all these I've mentioned so far, we can now say that natural number, set of natural number, okay, set of natural number is a proper subset of set of integers. I'll explain this shortly. And this is a proper subset of set of rational numbers, and it's also a proper subset of set of real numbers, and this is a proper subset of set of complex number. Now this arrangement is very, very important for you to know, because it helps you to rightly categorize them into where they belong. Now natural numbers can be seen from a set of integers, because integer is both positive and negative, so we can also get positive numbers from a set that contains positive and negative numbers. Set of integers can be in irrational, because let me just write the number system. 1, 2, 3, 4. This is natural number. You can see it from a set that is containing both positive and negative. You can see this one here in minus 1, minus 2, minus 3, minus 1, 0, 1, 2, 3. You can actually get this one from this set. So that's why this is a proper subset of this. You can actually get an integer from set of rational numbers, because when we pick two integers, it forms rational number. Probably we pick 1 and 3, or minus 1 and 2. It becomes rational numbers. Then all this can be found in real number system, because this one embraces all number systems, right? But to extend this one to something complex, that's why we have a complex number. So this is actually very needed for you to know. Now let's get a proof of how to be sure if root 2 is a rational number. We want to prove if root